In the previous video, we have implemented our digging mechanic and we have uncovered that there is one issue that our chunk is not updating the neighbors when we remove from it the edge block. So we are going to fix this issue in this video. Okay, so to do this, we are going to open up our world script again. Okay, and we need to go back to our set method that we have implemented. You can use this drop-down list to find your set method. And beside updating this chunk, we will need to add some code here to find out if our block is on the edge of our chunk. And if it is, we will want to uncover which other chunks should we update after removing this specific block. Okay, so let me paste the code. So first thing, as I have said, we need to find out if our block is on the edge of our chunk. So we are going to pass the chunk is on edge to the if statement, and this is on edge method will take chunk.chunkData. So this is the data behind our chunk and our position that we have calculated. So what is the position of this specific block? So if we get this if statement, we are going to perform some other logic, but let's start by implementing this method. So let's right click quick actions and generate this method inside our chunk static class. Right click on this and go to the definition. Okay, so this will be inside our chunk static class at the bottom, I think. And in here we are going to create logic such as vector3int new position equals get block in chunk coordinates. So we need to get the block in chunk coordinates. That this method was implemented again in our chunk, and it simply converts the world position to chunk position. So we are going to get the values from 0 to 15 or to chunk size. And next we need to create this if statement. So if new position.x is equal to 0 or to the chunk size -1, this of course means that this is on the edge. So if either x, y, or z is equal to 0, or our x, y, or z is equal to chunk size -1, of course y would be checking chunk height -1 because the chunk height is a bit different. So in case any of those conditions is met, we are going to return true, else we are going to return false. Now we could of course call this right click and rename, and let's call it a world position, since this makes a difference for us if this is a world position, and we can rename this one to be local position or chunk position, since this is pretty important. Okay, so with this done, let's go back to our world script, and we have received our response if this block is on the edge or not. If it is, we need to get a list of neighbor chunks. So to do this, we are going to create a neighbor data list. So let's maybe type list of chunk data, since this will be easier for our Visual Studio to create this method. Neighbors data list equals chunk.getEdge neighbor chunk, and we are going to pass here chunk data and the position again. Right click on this method and generate it using the quick action menu, and right click on this and go to the definition. Okay, let me paste the code here. We are going to have a pretty long if check. So we are going to pass here a vector3int new position, which again, this will be the world position and this will be the local position. We can simply right click, rename it, and let's call it world position. And this will be vector3int new position, so let's call it maybe local or chunk position. This will be equal to get block in chunk coordinates, chunk data, and the world position. If we have this, we will need to have a list of chunk data neighbors to update equals a new list of chunk data. Now below there is a set of if checks, so basically we need to check if our position.x is equal to 0, so if on x we are at the position 0, we need to get a chunk to the left from our chunk. If this is 15 or the chunk size -1, we need to get the chunk to the right, and this will be again for y, it will be up or down chunk, and for z it will be chunk forward or chunk backwards from our current position. So this is how we are going to access the correct neighbor. So again, we will need to have a set of if-else statements. If x is equal to 0, then we are going to add to our neighbors to update, add world data helper, and we have this getChunkData method, but we haven't checked or changed its protection level. So if we right click on this and go to the definition, we will see that this is a private method. So I will make it into a public method. Okay. And this is our method inside our world data helper. And this simply gets the chunk data from a position that we pass to it. Let's go back to the chunk script. And here we are going to get the neighbors to update, add world data helper.getChunkData. We are going to pass here the chunk data, the argument that we have passed to this method .world reference, and we are going to have the world position minus the vector3 int.right. And this is simply vectors 1, 0, 0. So if we want to get the chunk to the left, because x is equal to 0, so we need to get the chunk to the left. So if it is so, we need to subtract 1 from our current position to get the block inside the chunk to the left. Okay, so you can simply copy this statement and instead of 0, paste here chunk data.chunk size minus 1. So this is the last block in our chunk in the x-axis. We're going to add to our neighbors to update simply world position plus the vector3 int.right. So we are going to add 1 to it to get the block in the chunk to the right. Again, we can copy those statements and do the same for y-axis. So for y-axis equals 0, the only difference will be that will be world position minus vector3 int.up. So this is 0, 1, 0. And for the y equals chunk data.chunk height minus 1, we are going to simply add to this world position 1 on y-axis. And the same will be on the z values. So for the z value z equals 0, we are going to use vector3 int.forward, which is 0, 0, 1 vector. And if z is 0, we are going to subtract the 1 from our current position of the block. For z equals to chunk data.chunk size minus 1, we are going to add a vector3 int.forward, so add 1 on the z-axis so that we can get the correct chunk. Now we cannot really add the else statement because our block can be on the edge of our chunk. So this would mean that we will get the position to the right, to the left, for example, and downwards. And this will mean that we will need to, a couple of those conditions will be checked. So this is why we need to have all those if statements instead of if-else statements. So at the end, we are going to simply return our list of chunk data to get the neighbors that we need to update. Let's file, save all, and let's go back to our world script. Okay, so we have this list, so we can look for each var neighbor. So this would be the chunk data, neighbor data in our neighbor data list. For each of those, now the first line, we do not need this actually, because we want to only set the modified by the player to the chunk that was actually modified, and the rest of those the neighbors will be rendered correctly because the data will be in the dictionary when we render those additional chunks. Now the first line in this for each statement will be chunk rendered, chunk to update. We are going to access it by calling world data helper get chunk. So we want to access this chunk renderer. So to the get chunk, we are going to pass neighbor data.world reference and the neighbor data.world position. So let's right click on this method quick actions and generate it. Okay. And at the end, if the chunk to update is not equal to null, we are going to call to the update on this chunk. So we are going to update all the neighbors. And at the end, we are going to have the remaining code. So chunk update chunk and return true. So we have updated all the chunks. So last thing to do, we need to implement this getChunk method. So let's right click on this and go to the definition. Okay. So here we are going to have this simple logic. We're going to check if our world reference dot world data dot chunk dictionary, so this is the dictionary of chunk renderers, contains this key. So this will be our world position. We are going to return our world reference world data chunk dictionary and this chunk renderer on this position. Else we are going to return null. So let's make sure that we file and save all scripts, and let's go to the Unity. So now let's press play. And let's see when we generate our world. Okay. I think that here we are going to reach the end of our chunks. And let's Ctrl-Shift-P to pause our game. And let's see where we are now. So this was the current chunk. Let's click F to focus on it so our camera will not clip it. Let's see. Here was the last chunk. And this was the remaining chunk, so the neighbor. So here we had this line crossing, and this block, if we take a look at it from the bottom, has no face here generated. Okay, this doesn't look terribly helpful. So now if we unpause our game and remove this block, as you can see, this and it was blocked from our chunk that was a neighbor, and both of those has faces here. So now what we could do is also to check if, for example, here we are going to update both of those chunks. So let's go to our corner of a chunk somewhere. Okay, and I think this is here. So as you can see, we now have affected this chunk, and I think we need to dig one block down. And now we have updated this chunk, I think this one, and inside this one, and inside this one. So basically, we should be able to dig around here, and it all should be updated correctly. We should not see an empty space anywhere. Now, of course, it will not work for our water because we have no logic for the water to flow through those holes. But basically, now we have our digging mechanic complete. Last thing that I want to tackle here is the generation of our chunks that are underground. In our world, we had this method called getPositionsThatPlayerSees. Let's right click on this. This was in the generate world. Let's right click on this and go to the definition. And in here we have received those chunk positions around the player using the world data helper. So I want to go to one of those methods. And here we have in the get chunk positions around the player, we had this if statement to get the positions underground. And I have told you that we are going to wait with this code until we implement the digging mechanic. So let's uncomment this code, Ctrl-K, Ctrl-U to uncomment it. And we have those checks here. So this was for the get chunk positions around the player without one added to the range. Now below or above here, we should have the second method. Here it is. Now here we want to again uncomment this code. And we are not going to play around with adding one to this. Let's now test, let's for now test if this all works. Let's save this class, and if we go back to Unity, okay, if we try pressing play now and regenerating our world, we're going to get an error. Now exception is need to ask world for appropriate chunk. So this is the error that we have thrown inside our set block in our chunk static class. And this is something that we have forgotten to implement, or actually I have forgotten to implement, because it was not needed until now. So what we are going to call here is our world data helper.setBlock, and we are going to pass the chunk data.world reference, local position, and our block type. So as you might recall, I think in the previous video we have implemented this method to set the block type for the specific position. Okay. So let's make sure that we file and save all, and let's go back to Unity. Okay, so if we press play now, we are going to see that our chunks were rendered pretty much correctly, and our lower chunks were also rendered for some reason using our setup that is incorrect, so we do not want to render anything here. All of those should be set to be of type block, there should be no error, and of course we can see that we have loaded those chunks, so we have this data, but for some reason we have also used Perlin noise value on it. Okay, so how do we find out what is wrong? Well, I'm going to go to our world script. Great. Now in our world generate world method that takes the parameter, we are looping for each of those chunks, we remove them, and at some point we are generating the chunk data. So let's go to our for loop that loops for each position in our chunk data positions to create. And let's add a breakpoint here at the line 59. Now I'm going to exit the Visual Studio full screen mode, and I'm going to simply attach this line to Unity. And now if we go back to Unity, okay, make sure that you have this checkbox debugger attached to be blue. I think you need to click it to enable it. You can now press play, and when we click on regenerate, our Visual Studio should be shown, or you can click it in your taskbar. So we can click this, I think, step into, so F11, and we will go into our generate chunk data. Now this is all great, we are entering this for loop, so let's click again this F11 to go into this for loop, and now we are processing the position X and Z, which is 0 and 0. If we again click on step into, we are going to go into process chunk inside our biome generator, and here will be our issue. Let's step over, so F10, and here, what is going on here? We are calling start layer handler dot handle, and we are passing y equals 0 until y is less than data.chunk height. But our chunks beneath our terrain has the y equals to -100 or the minus chunk height. So here is the culprit. This for loop is passing wrong data on the y coordinates to our layers. So let's stop debugging by pressing the square. We're going to stop our game from executing the code, and we are going to go back to our Visual Studio. Okay, so inside our biome generator we have this bug. Inside our process chunk column we are using this for loop, and in the for loop we are going to, instead of calling 0, we are going to call data.worldPosition.y. Let's copy this because we are going to simply loop until y is less than data.worldPosition.y plus data.chunk height. Now in this instance, for example, if we go to our air layer, you can see that we are taking in the X, Y, and Z positions, and we are checking the Y position against the surface height noise. And as you might recall, this is some value like 8. So if Y, which will, in our case, for the underground chunks will be -100, is -100 is greater than 8? Not at all. So if we go back to our Unity, we're going to see that in our terrain generator, our biome generator uses the water layer, then air layer, surface layer, and at the end, we are entering the underground layer, which is the last layer. So if we edit it, it is checking if y is less than surface height noise, and that's exactly what is going on. In our case, we are going to set the chunk block to be this block type, and in our case, it is dirt. So now, if we save it, if we press play, we should see that if we regenerate our map, we are going to have the correct, or rather we are not going to basically see anything, but we have a way to visualize our chunks. If we select all the chunks, now of course you could have provided a better way to store those chunks in one parent object. In any case, let's select all of those chunks, and in our chunk renderer script, we should have this show gizmo. And as you can see, we are rendering all those gizmos, and our gizmos takes 6 chunks at the bottom. So this is the second level, this is the first level of the underground terrain, and those are our chunks at the top. So we have rendered correctly our chunks, or rather we have those chunks rendered, and all of those are set to be dirt. We do not render anything, we can only show this gizmo. So we can disable those gizmos, and now let's select this chunk render script and disable those. And in our game view, we should be able to now dig into the ground without any issue, because we have those chunks loaded correctly underground, as you can see. Okay, let's select this tunnel, and as you can see, this is our tunnel. It is rendered only the faces inside the tunnel, but basically we can dig forward. Of course, our camera is a bit misplaced here, it is clipping through our underground terrain, but basically we can delete those chunks here, those blocks, and you can see that we can dig underground. We can look up, and here is our exit. Again, we can press V and spacebar, and of course now we have this underground digging possible. And as you can see, here is our tunnel that we have generated in the underground chunk. Now we are not going to go any further with this system. Of course, when you are underground, you could have unloaded all the remaining chunks around it. You could focus on only those chunks below the surface of the terrain. Now this is something more advanced that you might want to tackle to make this world generator, this voxel world generator, more efficient. And I think that it is finally time to implement our multi-threading, because when we are moving, this is driving me crazy when we need to load, wait and freeze to wait for all the chunks to be loaded. So I want to mitigate it, and in the next video we're going to start working on the multi-threading so that our world will be loaded on the fly. We will not have those severe FPS drops. Okay? If you're enjoying this tutorial, please leave a like, leave a comment, subscribe to the channel, become a patron or YouTube member. It would help me a lot. And if you want to explore how to create a 2D platformer, learn a bit more how to structure your code base a bit better, how to use design patterns in your game code, check out my 2D platformer course. Okay? See you in the next video.